All right. And okay, guys. So what's going on this week is I finally yesterday, if you have notifications turned on for Google Classroom on your phone or whatever, then you might have been driven crazy yesterday because I posted all the week stuff. And so if you're getting the ding, 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 and it's driving you mad, I really want to encourage you to turn off the notifications. And just check this document right here, the lesson plans every day, and check Google Classroom every day. And that way you're doing it on your time and you're not letting me bother you on your time, right? You need to have time set aside for math, and that's math time. And then when math time is over, you're done. You put it away. And that's true for everything in life. Like, you don't want people to bother you when you're doing something important. Okay. And so really manage the notifications that you get in life and manage your boundaries when you say no to people. Okay. Sometimes we think that we have to be always turned on and always open to everybody. And that's not true. That's not the way the human brains work. If you're just coming in, be sure to, I think that's Nathan. Morning, Nathan. And if you're just coming in, make sure you have something in the chat box. And so this week, so today is graphing absolute value and then graphing linear inequalities. So you have two short assignments. I say they're short. I don't think they're too long. And the reason we're kind of speeding up, and normally I'd want to have like a remediation class, is I'm trying to beat fall break because I don't want you to have to carry stuff over with you fall break. Like, my idea is you can take the test and then you're done over fall break. Okay. So you'll see, like, next week we're doing linear programming and then take the test on Friday. And so it'll be posted earlier. You'll have everything posted for the week so you can move ahead. But after that's fall break, guys. So we're already halfway there. So, all right. Okay. I did grade the formative. So the formative, it looks something like this. Okay. You guys can see my screen, right? This was a common thing is when you guys write interval notation and you have infinity, you guys, there's a few of you guys that are thinking like, okay, I need to explain infinity as the positive value of infinity. And you don't need to. Okay. The idea of infinity is positive by definition. And so if you have a negative infinity, like, look at the second row has the negative infinity right there. That's correct. But you don't need the plus. I know what you mean, and I didn't take off points for it. But it's just not something you're right. So if you write infinity, like the third line is done more correct. Okay. And these are good. These are good, by the way. So let's see what else. Here's a really good example. I like this. Some of you guys were struggling, like on the right, you'll see somebody did it in Kami and they put the work in Kami. And on the left, they did it on paper. And I think that the paper is definitely how I would think it would be easier just to show the work, like they put the work on the bottom. But everybody's different. You don't get any points off for doing it on Kami, and certainly I included Kami on the test tech assignment, or tech test assignment. This person was thinking absolute value bars. You would get, if you had absolute value bars, you'd have two answers, like the same way you would over here, but you wouldn't have a range. And so the inequality is just written just like that, like up here, like 5 is less than x plus 1. It's just like that. So look at this would be more correct over here. X is less than or equal to 1, or X is greater than 3. That would be the inequality form. And it's expressed the same way as the graph, or expresses the same idea in the graph, and then interval notation. Okay. And I want you guys to be able to go back and forth between graph, inequality, and interval notation, and saying the same thing in all three forms. It's just saying it a little differently, okay? And you know, for some kids, like I have them when they struggle, I have them look at the graph. So for me, I can write interval notation really easy from looking at the graph because I just read it left to right. Start on the left, I'm starting at negative infinity, and then I go to 1 and I stop, or in this case, -1. And then I'm have nothing, and then I start at 3, and then I go forever and ever and ever to infinity. Okay, so it's a little bit harder for me to write the interval notation from the inequality. So if I start with inequality, sometimes I'll just draw the graph real quick, just so my brain can piece it together a little bit easier. Okay. This person on the right also put down a U, and you've been trained your whole life to write the letter U with that tail on the end, and you don't need it for this. A union sign is a math symbol, and there's no tail on it. It's just an uppercase U, no tail. Okay, so it would be like, and again, I didn't take points off for it, but several of you guys are doing it. But a U, that's a union. That is a union. Okay, and so interval notation right here, we should have a union between them. Now union means or, so when you write the word or, you're not wrong. It's just a matter of syntax, and I want you to, you know, get used to doing it as properly as you can. But again, not really wrong, and so I didn't take off any points for it, but I did get these graded. Okay, so let's see. Oh, one more thing right here. Do you see how this is left as an improper fraction? Some of you guys use decimals, and some of you guys use mixed fractions, and all three are correct. They're all the same. For any type of math test like the ACT, or maybe you're going to take the Coyote or whatever, usually they're left as fractions, as improper fractions. So I don't see any point in doing any more work. Like if you have a fraction, I don't think it's worth your time putting in the calculator to get the decimal. So just leave it like that, okay? All right, any questions about those little things that I just talked about? And those are just me giving a little bit of feedback. And I'm not trying to call anybody out by using your work. I'm not like, I just picked out some that's really easy to be seen. I try to keep it, I do keep it anonymous. So you don't have to tell everybody, hey, that's my work. Okay, so any questions, type yes or no. Okay, thank you. All right, we're gonna have a rule. You gotta be more active in the chat box.
Hey,
Okay.
Mr. Brooks, I'm
Yes, sir.
still working on the graph and linear assignment.
You're okay. You're absolutely fine. Yeah, it's very asynchronous, so don't worry about it. Let's see. Did I go over this? Oh, this was cool right here. This person rewrote it. See how X is on the right in the top line, and they rewrote X on the left. That's a really good strategy because some people graphed this the wrong way, whereas they shaded, they had the 4, but they shaded to the left because they you know, it said where's my marker at? This came out to 4 is less than X. And so they saw the word less than, and they shaded this way. And it's just a simple mistake. Anybody can make it. So they rewrote it over here with X on the left, and that way they read it as X is more than 4. I like that. I really like that strategy. There's nothing wrong with rewriting it like that. Okay. Cool. Okay. All right. Let's see what else. There is an assignment where you have to solve systems of equations. Okay. So I put a video instruction in the assignment so you can watch the video instruction. But who here remembers Solving systems by elimination. Okay, tell me in the chat if you remember solving systems by elimination. Maybe you don't even remember solving systems. Maybe you don't even know what a system is. But does anybody, okay, was never taught that. Okay, kinda, okay. You guys remember it? It is technically a review. We are reviewing it. But if everybody says they don't remember it, might give me pause. I might have to take another day for it. A system of equation is where you need two equations to solve two variables, right? So if you have like x plus 6 equals 10, this is one variable and you can solve for x, right? But if you don't have one variable, if you have two variables, so if you have like x plus y equals 10, can you solve for x or y? Can you know what the value of x is or y is? Well, no, you can't. Okay, you can't. Because you don't know if it's 5 and 4 or if I'm sorry, not 5 and 4, 5 and 5. You don't know if it's 6 and 4 or 3 and 7. That's why you need two equations right here to solve the systems. And so there's a number of different ways you can solve it. But oh, now that you guys said kinda, I'll tell you what, let's play a game real quick. Let's just play a game, okay? I want you guys to think and probably write down two, I want you to think of two numbers and you should write them down, but get two numbers. Don't tell me what they are, but write down any two numbers, okay? So right now, think of two numbers and I want you to add them together. So sum them up and write that number down and then find the difference of them and subtract them. Okay. So you have the sum and you have the difference. All right. And I'm going to pick a volunteer and you're going to tell me the sum and the difference, but you're not going to tell me the two numbers. And I'm going to guess what the two numbers are. Okay, so you have two numbers. I want you to add them together. That's the sum. And then I want you to subtract them. That's the difference. So I want you to do that. Okay, so let's pick Nathan. Nathan, can you give me the sum and the difference of the two numbers? And then Lauren Ingram, you'll go next. Okay, so the sum is 102 and the difference is 98. Okay, so so just give me 1 second. So are the two numbers 102? Okay, all right. And then Lauren, what are your two numbers? What's the sum and the difference? You got them, Lauren? All right, Brooklyn, can you give me your sum and difference? Brooklyn or Lauren, are you there? Come on, guys. Oh, there you are. Morgan. All right. Thank you, Morgan. The sum is 89. What's the difference? 25. Oh, you're working on the assignment. Oh. All right. Are your numbers 57 and 32, Morgan? Okay. All right. So what did I do? Okay. So this is a cool game. I love doing this as a math teacher. And the way it works is like I set up a system. So I know it's two numbers. So it's the two numbers might be X and Y, whatever they are. And then Nathan's numbers were the sum is 102. So if I add the two numbers, it's 102. And if I subtract the two numbers, it's 98. So this should look exactly like that example in the last slide. And what I'm allowed to do is I'm allowed to add or subtract these down. So I'm just going to add down. So this would be 2x and y plus negative y is 0 and it's equal to 200. And so therefore I know that the first number is equal to 100. Okay. And then since I know the first number is equal to 100, then I can plug it in. So 100 plus y is equal to 102. Okay, and then the same thing for Morgan's example. So it'd be the first number plus the second number is equal to 89. And then x minus y, the difference was 25. Okay, and then if you add down, it'd be 2x is equal to 114. So x is equal to 57, and then plug it in and you get 32. Okay, because 57 plus y equals 89, subtract the 50. Okay, so that's systems of equations. It's elimination. There's actually 3 ways to do it. There's substitution, graphing, and elimination. And for review, we're gonna do elimination. Okay, so look right here. So I have my systems of equations and I'm allowed to add or subtract. Okay, so if I look at this, I'm allowed to subtract these and that's going to cancel off the y. This is what you're looking at right here, is something that's going to cancel or eliminate. I guess I should use eliminate. I mean, in algebra, we've used cancel for the last 4 years, but you're going to eliminate one of the variables. Okay, now you could subtract, but I always add. And the reason is, it's just, for me, I'm going to make less mistakes when I add. So what I want to do, you're allowed to multiply a row. As a matter of fact, you're allowed to multiply both rows. And as long as you multiply the entire row by the same number, then you have the same equation, right? For example, if you had 2x equals 10, and you multiply it by 2, that's exactly the same thing as saying 4x equals 20, right? Because, I mean, x is obviously the same still. And all you've done is you know, you've changed the numbers, but you've kept the proportions the same. So you've done the same thing. So I'm going to multiply this row by -1. All right. So I'm going to multiply this row by -1. And then that's going to give me 7x plus 2y equals 24. And it's going to give me -8x minus 2y equals -30. Now see how I multiplied everything by -1? Okay, so again, you're allowed to add and subtract the rows, and you are allowed to multiply the rows by number, any number. You can multiply by 2, -2, 6, -6, whatever you want. So now when I add down, it should be a little bit easier for my brain. So this would be 7x plus negative 8x, which would be negative x. And then 2y plus negative 2y cancels. And then 24 plus negative 30 is negative 6. Okay. And so if negative x is equal to negative 6, then positive x is equal to positive 6. And then what do? I plug it in. Where do I plug it in? Well, you can plug it in anywhere you want. Okay, you can plug it in the top or the bottom. It doesn't matter. I'm going to pick the top since it's 7. Actually, I'm going to pick the bottom because I know 8 times 6 really easy. So it's 8 times x. I know x is 6 plus 2 times y, and that's equal to 30. And 8 times 6 is 48 plus 2y is equal to 30. And then 2 steps, so minus 48. So minus 48 minus 48. That'll give me negative 18. And divide by 2, and y is equal to negative 9. And so that means that for right here, if you plug in 6 and negative 9, you get 24. And if you plug in 6 and negative 9, you get 30. Okay. And so that these two are true. These two work for both equations. All right. Now, I mentioned graphing. I'm just going to mention this real quick. This is a line, right? If it has X and Y, it's a line. So, there's a line somewhere, wherever it is, like these two lines right here. And this point right here is where they meet. So I know that this line and this line meet at the point 6, negative 9. Okay, now I could go to Desmos and graph these, but that's the solution is a point. Okay, all right. Can you guys tell me if this is bringing back memories from Algebra 1, or are you still lost? How are we feeling about this? Maybe 1 to 5. 5 meaning like, okay, I'm ready to go, Mr. Brooks, and a 1 meaning like, okay, I might need a little bit more remediation. Okay, 3, 3.5, 4. I remember this. It's not lost, but familiar. Okay. I'm sure somebody out there is like, whoa, I don't remember this at all. And that's fine. That's fine. We can work. Just something similar, but I think it's a little different. Okay. All right. The big thing is you can add or subtract down. Okay, and you're allowed to, and you're supposed to multiply the row by a number. Okay, so maybe we'll do just one more quick little thing about this. Let's see, let's clear all this out, and let's find the worksheet. Okay, so right here, the first one, if you add down, would anything eliminate? Yes or no? Well, this is not going to eliminate. That would be negative 6x. And this would not eliminate. That would be negative 18y, right? So you have two options. You can either subtract. If you subtract, you're going to get, remember, you want the same value right here. Like you want, and it could be x or y, it doesn't matter. If you were to subtract, you would have negative 9y minus negative 9y. Well, minus a negative is plus, right? So that would cancel this out. And you see how weird that is? You're taking a negative and you're minusing a negative and you're going all the way across here. That's why I recommend only adding, because you don't miss a negative sign. Okay, but you should be able to look at this and you should be able to say, I'm going to eliminate the y's. And like right here, same thing. Either multiply this row or either row by -1 and then eliminate the y's, or you can subtract. What about right here? So I'm looking at the Ys and there's 6 and 3. So I could multiply the bottom row by -2, but since this is already really close, I can just multiply either row by -1 and the X's will cancel. Okay. And some of these, like, yeah, number 9, you're gonna have to multiply both rows by a number. Okay. All right. Does that make sense? Did I explain that pretty well? The key is gonna be posted for this. It's not up yet. And then right here, this is where you, this is where the rubber meets the road, so to speak, you know, the word problems. Just remember there's two variables, there's X and Y, or, you know, you can use any two numbers and they're gonna represent the same thing. So I'll just do number 1 real quick. Large pizza at this place costs $6.80 plus 90x. Sorry, $6.80 plus 90 cents per topping. Cost of a large cheese pizza at this other place is $7.30 plus 65 cents. Okay. So this one, do you see how it's like a number plus per topping? This one you might need to think about y equals mx plus b. If you, this should remind you of y equals mx plus b. So the total cost, y is going to be the total cost, and that's equal to, well, take the pizza, so 6.8. That's the cost of the pizza, right? And then you're going to plus, and it even says plus 90 cents for each topping. So 0.9, and the toppings will be X. So the Y will be the total cost, and X will be the number of toppings. And then it's the same thing for the next one. You know, once you establish the variables, it's going to be the same for the other problem. So the next sentence, and it literally separates it by sentence. The total cost is $7.30. So 7.3 plus 65 cents per topping. So 0.65 times X. Now, this should look like y equals mx plus b. The mx is over here, but this is commutative. And so now you can add or subtract down. You can do this. You can either subtract and the y's cancel, or you can multiply a row by -1 and cancel. But for these, so the other way you can do it is substitution. And that would be like, see how y is equal to y, like they both have y and they're both equal to y. So I would just set them equal to each other. I'd say, here, let me switch to this. I would say 6.8 plus 9.9x is equal to 7.3 plus 0.65x. And then you solve. Okay. So some of them are going to be like that. And since we're on the test, it'll just be elimination. So I think that the next one will look a little bit different. Last week she sold 6 more than 3 times the number of CDs. No, it won't be. Oh, here we go. Number 4. At a restaurant, the cost for a breakfast taco and a small glass of milk is $2.10. So a breakfast taco and a small glass of milk is $2.10. And then the cost for 2 tacos and 3 small glasses is $5.15. So now it'd be 2 of the X's and 3 of the Y's is equal to $5.15. Okay, and then now you can solve this with elimination. So this one's set up where the X's and Y's are over each other. Okay, so it looks like the top of the worksheet. Whereas over here, you still have this as a possible way to write the equation. Okay. All right, questions on word problems. Somebody already said, ew, word problems. Yeah, I know, my favorite.
Yeah.
Word problems are like the pinnacle of the math. It's where the rubber hits the road. I love it. Okay. All right. So hopefully you guys wrote that down, because hey, I just did 2 of the problems for you pretty much. Just check the key. The key's not posted yet, but it'll be posted today, I promise. All right. The next thing is the absolute graphing. I want to talk about this one. So 2 people have already done it. Okay, this is done a little weird. I was trying to think about the best way to do this that was quick and easy. If you look at this assignment and you're like, oh
Hold
my
up,
gosh,
Mr. Brooks, I thought
yes.
we were gonna have a short class meeting.
Hey buddy, we're only 30 minutes in. We'll be out of here pretty soon. I think this is the last one. Over here, I like this because you can just click on this and go to part 1. So this is part 1. Use desmos.com to graph. Okay, so I'm going to graph this for you. I'm going to show you what I mean. So you're going to open up this document here. And this is where you're going to attach your work to right here. Okay, now watch. When you go to desmos.com, we talked about this in the task where you use oh gosh, where am I at? Let's see. Let's get rid of this. There we go. All right. So we talked about this in the class where we graph these absolute value inequalities, not inequalities, absolute value. Okay. So we know that this is a V. We know that there's H and K and A in it. Okay. And all this is here. So like before you get to the assignment, you're supposed to remember like, okay, there's A, H, and K, and then there's a vertex and each one has a slope. And then this one explains, how to do the bars. So it's above the enter sign. And then this graph tells you if you want it, when you're ready to take your screenshot, use Control Shift plus this button right here on your Chromebook. Okay, now every computer is a little different. I use this little mono snap tool, but this is what you're going to do. You're going to take a screenshot of what you got. Okay, so part 1, it says graph these 6. So this is negative absolute value x minus 1 minus 1. So come over here to Desmos, go, and you can do this by hand if you want, but x minus 1, -1. Okay, now, so this graph has a vertex of 1, -1, and it has a slope of -1. And it's not like it's slope in parentheses. So it'd be, down 1 over 1, down 1 over 1, down 1 over 1. Okay, but you're going to take a screenshot right here. You're going to go like this, and then that's your screenshot. Okay, and then you're going to go back to this and you're going to go paste. And I just realized I need to give this to you as a PDF. Let's see. So bring to front. So I'm going to redo this as a PDF so you can attach it right there. Where's my order at? Just see, I'm doing this, and then I just realized what's going to happen. So basically, like, you can just do that. Like that's your graph right there. Boom, you're done. So you can do it by hand or just do it in Desmos and paste the graph. Okay. All right. Questions on that?
No, I just really want to work.
Okay. All right. We're almost there. Okay. And then part 2 is you're going to write an equation for these. So there's a video right here where I go over it. But if you think about it, if you just think about A, H, and K, and you have a slope, you should be able to write an equation for these, right here. Where's the vertex at? Plug in H and K. What's the slope? Plug in A. Okay. And then this is G and T. So you're just responsible for part 1 and part 2. And if you want to do the G and T, then come over here and do the G and T section. Okay, try those. All right. G and T stands for gifted and talented, and I haven't put it in place, but my goal for next year is to have a gifted and talented section for kids that want to, really strive. Okay. All right. So that is the graphing absolute value assignment. Because that's set up differently, I wanted to make sure that you saw how I do it. Okay. All right. Any questions on those two assignments?
No.
Okay. All right. Okay. So we talked about all that. I'm good. Okay. All right. The rest of that's geometry. Okay, guys, the last thing I'm gonna leave you with is I have all the keys posted and you guys have all the help you need and you guys can you know, do things the way you need to do them. Challenge yourself is my recommendation. You want to grow. You don't want to, you know, graduate high school the same as you came in, and you guys are already juniors and seniors. So, you know, you know, you don't want to, you want to challenge yourself so you can grow. If you don't challenge yourself, you're not going to grow. And you know, I think it'd be a shame to go through high school and not pick up on new things. And it's not like you're going to graph absolute values for your job, okay? But you're going to think about problems and use technology, and you're going to find solutions, and you're going to apply like why is this that way when it, you know, you got to use some, you have to develop some critical thinking skills. Okay. So I really want to encourage you guys to challenge yourself so you can grow. If you're not challenged, you're not going to grow. Okay. All right. With that, I'm going to stop recording. I am done.